It's tenris.org, and if you click on floodplain mapping, you'll see this overview. And it's meant to be a narrative, and it kind of tells you about our history. You can see that the CTP agreement, this Cooperating Technical Partners Agreement, is on the website, and it tells a little bit about the history of our group. And a lot of these high water marks are important because a lot of the floodplain, the floodplain mapping models don't actually get calibrated all the time because the information is not there. So this is an attempt to try to get that information all in one place. So if you click on those little triangles, you can actually see when the flood took place, what kind of information is available for that point. Currently we have 9,700 high water marks for the state, which I think is pretty good because we started out with 0. We know that the communities, not all of them have GIS. Only 25% of the communities actually have GIS. So we serve up the high water marks in a geospatial PDF, which is an Adobe Acrobat file that you can click on, and it acts like GIS. You can click on and off the layers. It's something that we can provide to the communities, and we have in the past. We also provide web services for people that do have GIS, and the web service is at the bottom of the page. It's pretty long. If you need it, you can just email me. But web services allow us to supply you with the most up-to-date file. And this is what the state looks like overall. If you can see, Harris County has the most high water marks, and that's due to the Harris County Flood Control, which I think of every time I say this because 2,800 is quite a bit for one county. And the second most populated area is, I think, Dallas County and the Tarrant County area. So this is what we had as of last week. I think the good thing about having the high water marks in one location is, like, the past couple of weeks we've had rain events, and we've actually captured high water marks within a very short amount of time, and they're in the system. So it's a way to not only just try to capture what's happened in the past, but preserve what we're getting, as floods happen. I want to talk about some of the uses that we've been, once we got them together, we're actually been using them to, like, calibrate models. And you can see in this case, actually the floodplain was actually lowered quite a bit, 10 feet once the high water marks were available to the people to model. And it doesn't work. It doesn't always lower the floodplain. It might increase the floodplain. So you might have a floodplain that's undersized. If you have a zone A, if you have a lot of zone A's and you can't get base flood elevations, this is an example of how at one point there's 3 high water marks, and if you overlay the contours with the floodplain information, it lands about elevation 34. And how the high water marks come into play is you see 3, and they're all between 32 and 34 feet, so elevation 34 is actually pretty good. And you can see here in a cross-section view that if you gave someone elevation 34 and they'd be down in the floodplain a little bit, and actually maybe 40 feet would be good enough for people to build, because you don't actually want to build, in the floodplain. But all these events were actually very large events. Hurricane Beulah and Hurricane Fern, which is lesser known because in 1970 Celia came along, and there's no high water mark for Celia, but I'm sure it was in that range of 32 to 34 feet. So another use of high water marks is if you live in an arid area, and in this case this is Amarillo, and the city of Amarillo is real generous in sharing their history of Playa Lake elevations and how high water marks can help you. In this case, we put the high water mark in the center of the Playa Lake. And some people see, well, I like to live near water. I live in Amarillo. It's only 15 inches of rain a year. I won't flood. But here you see the contour line against the high water mark, and you can see all that area does flood and has flooded in the past. So it's a good way to convey people a risk. And it's a real risk because there's a date, and elevation tied to it. And this is another example of using high water marks to communicate. This is in the Round Rock area with Tropical Storm Hermine last year, September of 2010. Some houses flooded and some houses didn't. Well, some houses are lower and some houses are higher. And this is a way to show them where the house was and, you know, how one side flooded and one side didn't because one side's actually higher. And also, we ran across another high water mark, which is almost the exact level as Hermine, which is May of 1981. A lot of people talk about May 24th, 1981 is devastating Austin. Round Rock got hit as well, but not that many people know that. The high water marks convey maybe a history that has been forgotten. And then some of you that are wanting to get their floodplain studied, high water marks can also be a reason to justify maybe a restudy of your area if the model doesn't match the high water marks. So CNMS is Coordinated Needs Management Strategy, which is FEMA's way of looking at where there's a need for flood studies and where there's not a need. So you know, the more high water marks you get, maybe the better chance of your area getting studied again. So we go back to the website, we see down at the bottom, this is, the website was in transition when I actually got the screen prints of this. You can see the next item is low water crossings. And low water crossings can be a risk because 80% of all flood deaths actually happen in vehicles. And so a lot of people, maybe they're new to the area, they see water over the road, they'll drive over it. And this is a way and a means of showing where those roadways overtop. In fact, recently, as the Office of Emergency Management around the area called the roads closed, we've been going back to look at if the roads have overtopped and compare that to our low water crossing data. So we had a few low water crossings a week. So we have overall 5,800 in 227 counties, and so we hope to get some help in those counties that don't have any low water crossings identified, if low water crossings exist. So the next thing I want to talk about is elevation data. Some of the counties are receiving elevation data. About 32% of the state of Texas is mapped with LiDAR, and that's about 84,000 square miles. 6% of the area is still in progress, and so we're still looking for partners to go out and get elevation data. And this is LiDAR data, by the way. And we're also looking at other data, which is, this is a cross-section that compares National Elevation Data Set, which is USGS, which is the basis for most of the floodplain maps in Texas, and LiDAR, which was taken in this area, and then a new product, or it's not really new, but maybe a lesser known product called InterMap, which is FSAR. And you can see that FSAR and LiDAR compare actually pretty well, the green line versus the red line. And actually in this case, the FSAR, the InterMap data, is actually better than the LiDAR. So what we're proposing to do is, if you're interested in elevation data, look at this other option, which is the InterMap data, and see if that fits your needs, and see what's the most cost-effective way of capturing the elevation data. So that's something new that I hope to launch off here in a little bit, a tool that will actually show you these comparisons and show you how the National Elevation Data Set compares to survey data or whatever data is out there, so y'all can make that decision. We're also having a presentation at ASFBM, and that goes into more detail on this one subject. We provide geospatial PDFs, which is, we provide your floodplain map on Adobe Acrobat file that you can turn on and off layers. We can put contours. You can see here we have contours, high water mark, flow water crossings, and even parcel data that the community provided. This is for the city of Dickinson, and they're hoping to use this map and get credit for their CRS rating. And also at ASFPM we're presenting to show how we use geospatial PDF to help the communities that don't have GIS I don't know if you guys remember, I said about 75% of the communities do not have GIS, and yet, you know, we've gone paperless. So this is the way to help out communities and make it a little bit better for them to access their floodplain maps, because you can see the aerial image over the floodplain map, and then you can see other data. And finally, we're updating our business plan. At the end of the month, we hope to present that to the Water Development Board. And we're also working on mapping activity statements with FEMA. And I can already see more communication between all the cooperating technical partners, Harris County Flood Control, Sarah, and City of Austin, and some of the other people that participate in FEMA to try to restudy their area. So I think that in the future we can see a lot of more cooperation and you know, a lot more movement in getting better floodplain maps for Texas. We need you know, help. Don't hesitate to call. Sometimes the phone rings and rings, and you leave a message, and we'll get back to you. One morning I started off at 8, and I didn't get off the phone until 12. So sorry, and I'll return your call. Don't worry.